This is the Recall Singularity. I'm just posting online that I'm starting a stream so that everyone can come and view. It felt like a bit silly to post that and not tell people. So I just like to put this post inside of the other one so that people know what I'm talking about. There we go. So, to get started tonight, what is the plan? Pull out the trusty notebook and flick to the plans section and read what's next. So, my plan was frame by frame to send a player action to the server. Well, we did that last night. And networked player movement around the ship. We're going to do that now. Able to begin interaction with the console. Ship movement with keys, we've got that, but not rotation. So first things first. I probably shouldn't. Oh, I didn't announce it on my Discord. Let me just quickly tell everyone on my Discord that I'm kicking off. So hold on a second. Might as well put this over here. So and here have begun Discord streaming on further input stuff and then I need to put the URL to the stream that you are doubtless watching right now, which is kind of a strange thing to put when doing that. Cool. Hey, you're famous word constructor. There you go. You right there on the stream. Anyway, oh, and I need to find the chat window. Somewhere in here there should be a chat window defined. So I'll close that. I should have a little, let's see. I hope I didn't just start playing some music. I don't think I did. Oh, it's already, the chat room's already here. Okay, silly me. Cool. Here's our code. So I took the liberty, before we started the stream, of committing the last work that we did to Git. So what we did last night was add inputs for ships. That's now a new commit, all pushed up to the server, so we're ready to go. Well, kind of. I'm just going to quickly run what I've got. So let's run the server and have a look. So what I've noticed, what I added last time was the ability for inputs from the user to go up to the server and move the ship. But when you tried to rotate the ship, it didn't rotate. I'm thinking that it's because I probably didn't synchronize rotation. So here's a ship. So hold on, it doesn't seem to be doing anything with my inputs. Or am I just being too impatient? Okay, this is a bit embarrassing. It's not moving at all. I was expecting to see that ship at the top move. Why is it not moving? Now I'm just trying to figure out why that ship's not moving. Which is really weird because last time we did this it was moving totally fine. Let's just quit the client and try again because maybe something funny is going on with the client not connecting properly. I could have tried building floors and stuff to check that. Here we are, now it's moving. So maybe something was going on with the synchronization and the networking. So see, I can move that ship on the top, back and forward. I'm just pushing cursor keys on my keyboard. I can move it in the other axis like this. So a couple of things we need to do. We need to rotate the player's input commands based on which way the ship's facing. I'd like to place the camera over the ship. Oh, it won't come back. Oh, I'm pushing the wrong button, that's why. I like to place the camera over the ship. I'd like to change the collider for the ship. Yeah, anyway, off it goes. See you later. Bye. So something funny probably happened the first time with the networking. And those kind of things we'll track down at a different time. I'm just trying to do the input right now. So if I was running two clients, you would have seen it move on both clients, assuming that it started in the same place on both. They would remain in sync. So another thing we need to do is transmit the position to the client when it joins so that we can ensure they start off in sync, and then if it starts in sync and stays in sync, then it's going to be in sync. Kind of a tautology right there. So I'm a little bit getting organized in my own head. Let's start by having a look at the physics. Okay, so in the physics is an SG core. It's in the yes, no. The SG core contains the logic that copies it from the ship itself into Godot. And I think that logic at the moment is actually in the process command. So this is part of my concern with how things used to work. If you were here last time, you would remember that we refactored this a little while ago so that this class we're looking at now, Star World Link, owns a sector, which makes things easier in terms of updating the ship. In this case, I think we're using an event to constantly notice the ship had changed. Okay, yes. I was correct before when I said that we're translating the ship, but I've forgotten to rotate it. So this is why when I try to turn the ship, we don't see it turning. I wonder if I want to move the spatial node right up there in the physics command or not. And if I did want to move it up there, rather than using the event, that places the ship. Did I do something hacky like use ship add every turn? Or how did I move it on screen? I can't remember how I moved it on screen. Oh yeah, update ships. Here we go. So every frame we would get the ship and we would, so it's using positions which are pos instances, but we'd ignore the pos instance and use a ship instance which we'd copied the position earlier. Is there something interesting about the spaceship? I don't think I put the rotation. Did I put the rotation in this? Yeah, I need an orientation also. There's some mind-melty maths here that I need to worry about at some point. But, and it's part of thinking about whether I want 2D or 3D physics that I haven't really faced. So, for orientation, let's just assume for now we want a full 3D physical location. The physical location is in this thing called pos, and it is a pos, and it's isometry 3, which is a class I don't fully understand yet. What we need to do is create from the isometry 3 a transform that we can use in Godot. Transforms are what moves all the different parts of a model to the right place on the screen. You have a few of them. The one we're interested in right now is called a world transform. It's probably this one here that I want to read about. Okay. So there's a rotation which is supposed to be a quaternion according to the other one. Quaternion or something similar. Yeah, 3D is harder. Transform a point, transform a vector. See, one thing we can do with an isometry is to transform several vectors and then pass them in as the basis for a transform, which would be the one of the ways to get this done. So let's have a quick look at how Godot's transform works. And as far as I remember, that was a really basic class. The only reason why it has any methods at all is because I put these here. So from transform takes the transform 3D object. That's the one that's fully fledged, and it comes from what library is this? This is uslid. So is it the same library as this one? No, it's in algebra. So we need to just go to docs again, and look for uslid library. Let's have a look. Okay, and in uslid we want to have a look at the transform 3D because we want to make one. Row major, column major, transform, ortho is 2D, yeah, I'm just trying to find constructors here that we can use. So the goal at the moment is to use a transform 3D. I wonder if I need one of those little widgets that you type a goal in to create a transform 3D from the isometry. It's going to open this window, it's really hot. Unfortunately, that makes the room just slightly more noisy, but you probably, compared to the microphone hum, you probably don't even notice. Sorry about the hum, by the way. So, Rho major. So the other way I could do it is by transforming and rotating it, which is how we've done it in the past. This transform, what was this transform class? Has a basis. It's a matrix containing a vector 3 as its columns, x-axis, y-axis, and z-axis. I could use something like a rotate y command with constructor. And this is something similar to how I used to have done it in the past. I was just trying to figure out if I could do it in some sort of fancy way. But I think I might discard that. So this is the way that I've created it in the past, what you can see here. So let's just grab that block of code that I used for placing meshes in the past. And we'll go back to the ship and we'll it'll be interesting to see if rotating the entire ship messes up. Oh no, it doesn't mess up my cursors and stuff in the game because I've already tested that I can click on things. A little blue cursor that moves around can manage ship rotation because I tested that in the past. Okay, so we have a ship. We want to create a transform. Why did I... just trying to find that place where I searched for what I found when I searched last time. Anyway, so we're on a transform 3D, which is from Euclid. In ship space. I wonder if that's going to come across. It's just trying to do a background compile to figure out what's allowed. That's like a unit of where the transform works. It's just like a feature of Euclid to make sure you keep your transforms making sense in some way. I don't want to scale the ship at this point, so we might start by I wonder which one we do first. I guess we have to rotate it and then translate it. That sounds about right. So it's probably a create rotate. So create rotation, and that will create a new transform that just does a rotation. And once we've got that transform, we can then immediately translate it or move the ship to the correct place. So we have to specify here, what are we specifying? X, Y, Z, theta angle. Okay. I wonder if that means we should rotate it on all three or apply a Quaternion. Because I'm wondering about whether I want to apply the rotation on all axes, because we're using a three-dimensional physics world, and our three-dimensional world's probably going to have rotation on not just around the y-axis but around the other axes also. So there's one from create translation. There's one for create from scale. Create from rotation. Create from skew. Create from perspective. And then there's some tests. We don't need the tests. Okay. I wonder if there's like a trick with quaternions where we can get the axis and the rotation around that axis perfect for the quaternion, but that seems unlikely. This stuff melts my brain sometimes, I find. Okay. Schutz spatial. So we're going to go back to the isometry. Transform, inverse transform point to homogeneous. Yeah, drawing on paper. The thing about drawing on paper is my problem is just understanding it. It's finding easy functions that already exist that I can just reuse is the ideal if possible. And so I need to like understand what's here. First, unit quaternion. What can we do with this? Angle, quaternion conjugate, inverse angle 2, rotation 2, lerp, inlerp, trislurp. Oh, this looks really promising. A rotation axis, we need that. And axis angle. So remember how I just told you that it'd be nice if you could find an axis and then you could find an angle? Yeah, well, this is literally what these two functions are doing for us. Okay, so now we can, that's like a real gift. So for my own state of mind, I'm going to just put this documentation over here where I can see it and you really can't. And it's not because I'm trying to keep things hidden from you, it's just because I want to be able to see more stuff at once. We're going to work through this one step at a time. So we've got pos, and pos is an isometry 3. We want to get from pos a rotation and a translation. So let's get those. Let translation equal pos dot translation. I think it's called. I'm just back at looking at the I need to open a new tab and go back to the isometry 3 and isometry and find the one that's called transform. It wasn't transform I wanted, it was so what we essentially want to do is transform a point that's at 0, 0, 0, and that will put it at the correct place for the center of the ship. So let's just do that. We'll just transform 0, 0, 0 and it will give us, I mean, it seems kind of crazy, but you know. So the translation is equal to the pos dot, in fact we probably did it right here, center x, center y. Okay, so in this case I would have done it where I synchronized spaceship to pos, which is probably in the physics. Just trying to find where I've done this before. There's a member here called translation, iso.0.translation.y. So that's what we'll do. So for the translation here, let translation equal iso.0.translation, like this. So that's the location where we are. Let rotation equal iso.0.rotation. I'm just going to go back to the isometry here, and we'll have a look to see if it has a member. I see, here it is, rotation. And we know from before that that's a quaternion because that's what this particular template has. So this one here is a vector, and this one here is a quaternion, which is like a fancy way of rotating stuff. So then the rotation axis is equal to rotation dot rotation x. Pretty sure that's what it was called. We're going to go back to the unit quaternion, and it was called scaled axis. I don't want a scaled axis, I just want an axis. Okay. It says that it will be none if there's no rotation, which sounds like it could be handy. Also sounds like it could be confusing. It's like an edge case to handle. Okay, so let's just special case this. I don't really like special casing things like this, but we're going to figure out what the transform is. So let transform equal, and we're going to calculate on two arms. So the first one's going to be for rotation being true. So if some rotation axis is equal to rotation dot rotation axis, so if there is a rotation axis, but it's just called axis here. Looking at the docs on my left, you can't see. And then, so if there is rotation, we're going to create a simple transform. Sorry, if there's that's the complicated transform, and I haven't written anything there yet, so it's currently incorrect code. Otherwise, we're going to write a simple transform. So in the latter case, we don't even need. We only need a translation vector, so we can actually just use this. So I'm going to put that here, and we won't use the x location and the z location. I'm going to use a location from the this translation here. So this vector 3 and that vector 3 are probably different, because this one's, there's like two libraries in play, and the physics and the Godot integration disagree on the two libraries. We have to unpack the vector manually. So translated.x, translation.y, translation.z. So that's what we do if there's no rotation, and that's pretty much never going to happen. There's probably always going to be some rotation, like things don't tend to end up being zero. We don't want a curly brace there. So this one's going to also return a translation. And it's going to do it by creating a transform and then creating the Godot type from that transform. So let transform equal this, and this guy is going to cast it, and if I go into transform I can say from. So this is a Godot transform, and it takes as an argument the kind we're making. So I'm going to return from this arm of the if statement a from transform, and then here we're going to put the other transform variable. The variable names here are pretty very confusing if you don't know what the hell's going on yet. So in create rotation, the first thing we need to do is provide this axis. So we have the axis here. It's called rotation axis. So the axis is that dot x, that dot y, dot z. The angle we're going to get as well. The angle is going to be rotation dot, and over here it tells me it's called axis angle. Oh, axis angle doesn't. It's very handy. So if I go here, axis angle, then I can get not just the rotation axis, but also the angle that's rotating around. Okay, and then here I just need to write angle. So that creates the rotation. Now that we've done that, now we need to translate the vector. So we've rotated the ship around the origin, we're going to move it to its new location. To move it to its new location, so it's invoking a macro here. This is no longer required. That's the old code. It's invoking a macro here. Where are we? Called vec3. I just imported that. And then we use a translation again. So, in fact, it's just that. I'll put it in here. So there's a lot of messy, unnecessary conversions between different transforms and vector types going on here. Probably a lot more than is required, and tons of extra maths, and it doesn't bear thinking about too much, because honestly, it doesn't happen very often. Like, it's only once per ship per frame. It's not really that often. But down the track, I imagine I'll be managing like lots of little missiles or bullets or something, and I'll be thinking to myself, if I only had a better way of doing this. It would be really nice if it turned out the compiler just saw it was moving floats around and did something clever. Now, that didn't have to recompile the code, we just changed, which is about to fail to compile, because, you know, nothing ever compiles first time for me anymore. Used to once. Probably because I was using simpler languages. And I was trying harder to make it compile first time. Now I don't bother making things compile first time anymore. I just, I let the compiler figure out what's wrong. I just hack it up as much as I can and just go for it. Run. So I'm going to make that compile error happen again, but this time in a handy dandy little window. And then I can go in here. Managing windows. See, normally I spread out across 3 screens and I have so much space and tiny fonts, and that's wonderful, but having you guys along for the ride is so worth it, so I just have to make do with trying to cram everything into one little screen. Don't worry, you know, I still love you. Anyway, figure out it's not really mutable, cannot find value. That's why I work so hard to like use Windows to work, because I don't normally have to worry about it. Cannot find value ISO. Yeah, so I copied this code, but it's not called ISO here, it's called POS. And now it's complaining that that's not a struct. I thought it was returning, I thought axis angle, which is the one I called here, returns a unit vector and a value n. Create rotate. Does create rotation do more than? Oh, it expected this class called angle. I bet I can just wrap that in. I bet this class angle just happens to be a like a little check. You know, you just wrap your variable in something to check that you're using the right type. I probably can just write it in here that it's an angle. I want the usage one. If I go in here, it's waiting for it to realize that it exists now. Okay, it won't let me go in. Fine, let's just see if it compiles. Okay, so we need curly braces. It's probably something to do, like say from float or something. Maybe I need to deliberately call into. Okay, convert from is not allowed. Okay, so I need to stop just hacking things up and try and figure out what the hell this angle structure is. An angle in radians. So I'm supposed to choose either degrees or radians. Okay. And this other function returns radians. So I need to say I want this is angle radians. I understand why radians are mathematically lovely, but I still prefer degrees because they just fit better into my small brain. Okay, expected reference. So I need to put a ampersand there to say you can borrow it, but you can't keep it. Okay, so the game's ready to run. Let's try that out and see if it goes. So what's changed is that in theory we can now rotate the ship. Let's see if it's still busy. Oh my god, it's rotating. Do you see that spinning? That's so cool. Okay. Whee! Whee! So we should be able to crash into the other ship now. Oh, it's so finicky. Look at them rotate. So they intersect because the part that decides whether they're touching, the collider, is a lot smaller than the ships are. And because it is, so I wonder if one of them's going to end up being on top of the other soon enough. Because it's so much smaller. Oh my god, I'm spinning it, not flying it. Ah, it's out of control. Ah. You know, I have to tell you, this is freaking awesome. I mean, this thing's really moving now. It's very hard to figure out how to control this thing. Let's see. I was trying to get stop moving. And thrust upwards. Anyway, that's enough playing the game. I mean, whoever plays a computer game they're making, I mean, never. No, we don't do that. Okay. That was cool. This is annoying. Oh, yeah, good. I can move this. So I'll put that on the other screen. Okay. So, we can put a big giant tick on ships now rotate. That was really neat. What's also interesting to me is that the ships aren't buckling when they hit. I was expecting to have to deal with a problem where because I'm using a 3D engine, I have to like use it in 3D because I don't want to use it in 3D. I want a 2D 3D engine for now. Okay, so the next thing is collisions. To celebrate our success, I'm just going to very quickly commit all the work we just did. There's a couple of things here that are irrelevant, but wow, there wasn't much changes. Ships rotate into growth. Ship is now synced into go dot. I like committing because I don't feel any anxiety now that I'm going to break something I've made. If I do anything that doesn't work, I can just jump back and reuse that. So that's great to know. What was it we're going to do next? I've already forgotten. Something to do with rotation and movement. Yes, colliders. That's totally to do with rotation and movement. Okay, let's go. So I remember that being on the floor simulator that I put the code in. Because it's from the floor that you create the collider in the first place. So here's a floor class, and somewhere in here, well, it's probably somewhere else that uses as a floor. It was the action is adjust floor, and then this uses another class to manage the floor itself. Floor. This is very interesting. I'm just going to do a search. Colliders for floor. It's inside floor tiling. That's the one I was looking for. So colliders for floor returns a shape in the float F32 physics world. So it goes through this definition of what a floor is in my game. And then for every, it tiles the floor, and then for every tile it creates a cuboid collider that should describe which parts of the ship you can't hit. So we're going to just go and grab this, and we're going to go across into the physics world. We could call this every frame, but that would be expensive. What would be better is if when the floor is adjusted, we apply it then. So we might just put it straight into adjust floor. And we also need to put it in so that when the ship is first created, we do it straight away. Okay. Adjust floor. So there's some code in here that manages all the ways it can be adjusted. Here's how we apply the action. We either add or remove walls and floors. Do wall building here. Well, that's kind of irrelevant because that's now working. I guess there's an old to do. And here we're going to generate the colliders for the floor. So what we're dealing with here is an action that has access to the entire world. So because it has access to the entire world, it's just fine to use system data to get data. So we're going to need the floor. So here we are getting the things we need. So colliders for floor is going to require a floor. Requires tiles, which is I don't think I've even got a this concept of finding physics tiles. Yeah, that was the one I was looking for actually. I'd already gone to the wrong one. What does this one call that one? So that's finding the tiles. And that's returning a ship box and array. Okay. And what does colliders of floor do for me? I'm just trying to remember the stuff that I thought I'd figured out. Some inklings are coming back to me. I think what I needed to do was to get hold of a floor, use find physics tiles on it to get the information about where the colliders should be, pass those down to colliders for floor, and then put that into the physics system for a particular ship. Which is a way of saying if you have a floor and you have a ship, you can adjust the colliders for that ship. Okay, so we'll close others and we'll open floor. This stuff is probably not making much sense yet, but it will make sense as I do it, I hope. On floor array. Okay, so this floor class represents the area where you can draw to make the spaceships bigger. This floor class tracks where the person has drawn and said that they want the floor of their spaceship to be. It has an instance which is basically just an optimization to say where the floor is in space compared to the origin of the ship. So these ship boxes are basically left, right, up, and top and bottom, and it's like the 4 coordinates of a box. This array 2 is like a giant grid, and in that array I paint in a value of his floor there. I'm pretty sure I'm just using 0 and 1 at the moment, but I'm thinking that down the track I might want to put different things in those arrays, or I might want to simplify it to being a Boolean array, which might somehow improve performance, but at the moment it's just an array of bytes using the NDArray library for that. So what we're doing is we're adjusting a ship. So bulb function, we want collider for this, so collider for in the ship, so it creates a collider. So the collider looks like a shape. If I'm bad about that burping. Collider for the shape, which is an F32. And we're going to apply that ourselves to the physics later on, I guess. So shape comes from specs physics. So if you have a look at shape, it's a list of all the different collider shapes that one can specify on a physics object. Ball, capsule, compound, convex hull, etc. The one we're interested in most is the one that specifies multiple other colliders as sub-colliders, which is called compound here. So it specifies where they are and what shape they have. So we're going to make compound ones. So if you look in here, we create an empty compound shape. We add cuboids, which are basically cubes in space, and specify where they are, and we create a compound one out of the parts. So I've already got a unit test which makes sure that this creates sensible results, or at least I think I had one. Or maybe I just code it up and hope for the best. Yeah, I reckon I just coded this up and hope for the best so far. So we're going to find out if this works soon enough. What I do know is that this other one here, find physics tile, works because I've got unit tests for that. I think I got distracted by the networking refactor that I eventually reversed. Sorry about the truck, by the way, if you can hear it rumbling up the hill out there. There's a road. There's a road out there somewhere. Quite close. Okay. We want a collider for ourselves. So the first thing we need to do is find physics tiles. So if I just minimize this glass, you'll see that a floor has extents in a floor. We don't need a floor mask in this routine. You don't need to clone the floor. Or we do. So that's a problem, because I need to change this function signature so that it has the same arguments as what a ship box has. That's annoying. Oh well, it can't be helped. So I might just use extract routine to do this. So we'll what do I call this? Find physics tiles from floor. So I just used the extract method, and it took care of the fact that I want extents. So I got floor. It's just written out the entire definition of what a floor is, but I just want to call this an array 2 type U8, which is what I've been using for this type here. And here. Great. Yep. So first we want to find physics tiles from floor. We want to pass in the from self extents and self.floor, and these are both I'm surprised this hasn't put in as a reference. I don't really want to move it in here, so I'll put floor as a reference. Here it's a reference to. So this will return a list of all the different squares within the ship, as well as other useful things. I'm not sure if I need those things. So we don't need to know where the ship is in space. We don't need to know what its floor is. In fact, I'm not sure why I returned that. It's probably all the areas we couldn't tile or something similar. All we care about is the colliders. What's called tiles. And the reason why we want tiles, so we want to let that be. Then the reason why we want tiles is to find the collider. So we're going to pass the tiles into this other function called colliders for floor, which we need to import. And it takes tiles as input. I'm sure that's clear as mud. And that should return a collider that's built based on our floor. This file has my kind of bottom-up dynamic programming solution to figuring out which parts of the floor are tileable, which would require me to take probably about an hour to explain to you how this actually works. But essentially it's so that I can put those little tiles on that you see when you resize your ship. And we're reusing it for putting colliders into the ship. The difference between the physics version and the non-physics version is the physics version there's no upper size on the tiles. It doesn't care if they're really massive. That would actually be better. So that's what's going on there. Somewhat. I don't expect you to fully understand all of that. It's a bit complicated. We don't need to put collider inside of a variable. We just need to return it. So we could actually just do that. This is just a handy dandy way of calling those two functions in sequence in the end. Oh well. Okay, so the next thing we need to do is we need to update the physics collider whenever we process this adjust floor action. so that the physics collider is different. Part of the difficulty here is going to be realizing that the new collider intersects with an existing ship. So right now it's possible to actually build a floor around into a ship that exists. That'll be interesting. Probably the physics engine will do one of two things. Either the two will get stuck together forever, or they'll go pop, and the two ships will be pushed apart at great speed. Both results will probably be amusing, and either can be fixed by using the delete floor tool. So I'm not too fussed about them. Let's see how it goes. So we need to get a copy of the floor, which is the resource. You see it's being used here to read a floor. So, and in this case we don't even need system data, we just need to use fetch. That hopefully still work. Hope I didn't just break something. Down here, so in specs, this floor concept, the class I showed you before, the structure is resource. There's a question here. Weird Constructor suggests that he would write his own physics collision engine with only radius-based collision detection. Yeah, well, all physics engines that do collisions tend to do layered collisions. So you start off with something really simple like radius-based collision detection, and then once the two entities actually match on the radius, then you consider running a more detailed collision detection algorithm. But I'm very much in the camp of trying to reuse other people's work where possible, so I can get to my dream faster, as opposed to put myself through the pain of doing these sort of things myself. But you know, if you're having fun and learning, I mean, I've already done physics a bit, and I'm over it. And these guys have done so much of the work for me, so I'm going to use it. So great. Okay, so the class called Space at the moment manages a physics collider builder, and so I need to have a look and see how one goes about modifying the physics collider builder. So that'll be something we're going to do in a second. So let ship collider equal, and we call this colliders for floor. Let's double check it. Collider 4. Yeah. Build collider. So floor.build collider. Well. Thanks for all the interaction, by the way, guys. That's awesome. This is me trying to collect my thoughts. Oh yes, the floor came from this fetch read floor, that colliders for floor. So that will tell specs we'd like to get the resource called floor, and then we'll call colliders for floor on it. And colliders for floor will return us a collider to use into a variable, and then this whole thing, Rust will realize that we don't need this anymore because you don't use it again, so it'll go poof. And the floor itself is a list that we got created by that routine, so essentially it's like copying or generating something new. And then we want to move that into the ship. So let's have a quick look at Physics Collider Builder, because this is the first time that I've had to is it Physics Rust? Specs Physics. It's the first time I've had to make a collision outside of initialization. This is like the initialization here. So we'll go to the docs. Physics Collider Builder. Okay, so it makes physics colliders. So represents a collider. Shape. So we've got a shape, an offset from the parent, a density, a material, an origin, collision groups, linear prediction, angular prediction, and sensor. So one thing that was mentioned in the specs physics stuff is that when you change the shape of the collider, it will actually look at the forces you apply and change them. So it should be, when we make a bigger ship, it might actually act bigger, which is pretty awesome. I hope that's the case, and that'll be fun to play with. We probably have to tweak where we apply the force to put it in the center. So the thing we want to change is this one called shape. So we're trying to get a component called physics collider that relates to the current ship. I've just realized my problem. It's a pretty annoying one. We've got, and it's one I've known I had to solve for a little while now. But I'm not sure quite how to explain it to you. We've got this concept of the world that contains the floor as a resource, and then we've got another idea of a much larger world that contains all the ships, and each ship is a component. We need to get the floor out of the ship's world back into the space world where it's got all the ships in it. And that's another thing that was melting my brain a bit earlier on. So at the moment, this world we've been past here is not the one with the ships in it. So we can't change anything to do with physics from here. We have to do it separately. And what you essentially have, you have a couple of options. We could have events that are getting sent essentially from back to the sector from these subworlds. Yeah, that was a pretty poor explanation. Okay, so let me run the game. And it doesn't compile. Let me get the game to compile, and then I'll explain this to you. Run the build. So we're just quietly waiting while I fix these compile issues to do with the code I just wrote, and then I'm going to explain to you what I meant. Why is this floor not working? Yeah, I don't really care if this doesn't return those and just returns a vector of ship boxes, so I'm just going to do that. It's going to blah blah blah. Once I've got this up and running, I'll just come back and explain to you what the hell's going on. So I need to just, those variables need to come out. Some bad commentary going on right now. I'm just too involved in trying to fix these boring compile issues. Okay, I just ran into an annoying bug in CLAN where it makes a really big box. Okay. And then here, it just needs to be tiles. It does no longer need to be that long. Okay. I think it's compiling now. Great. Let's run the game and I'll talk you through this. I need to just quit the server if it's already running. Server stop. So run the server. Great, it's running. Run the game. Just waiting for the server to compile. Okay, so the world, my world, has spaceships in it, and those spaceships exist within I need to remove that diagnostic output. Those spaceships exist within a larger space. So there are don't go away. Oh, twitchy, moving spaceship. There are two spaceships here. There's this spaceship, right? And then over here, there's another one. And I can expand both of these like this, right? Individually, they are separate. The one that's up the top here. There are two different ways that we can talk about the spaceship. So first, there is a world containing two spaceships in it, and in that world we reference that there is a spaceship here with this location, with this rotation. All those qualities about that spaceship are stored in the star world. And then in addition to that, let me move the camera up here. I know my player movement controls are all wonky. I just thought it'd be fun to try that. This world and the tiles that are in it are determined by are stored in a different specs world. So there's one specs world that remembers the tiles that are in this ship and manages the way that things like scoops and stuff in here work. Here's a scoop, creating some gold. Here's a refinery. This stuff comes out of it like this. Let's just see it come out. So there's a world that's managing what's going on that ship, and then there's another world that's managing what's going on this ship. It's a completely separate specs world. So for every ship we have a different specs world, and the rationale behind that is that as the number of ships grows in a sector, I don't want every client to know about every ship. I don't want them to know what's inside every ship. I don't want them to have to worry about simulating them either. So I wanted a very granular, but I also want ships to run in lockstep. So I want you either know everything about a ship or you know nothing about a ship. And if you know everything, you can simulate what's going on in the ship yourself. The server just has to send you small updates about what people are trying to do to the ship. So here, in this game, we have got 3 specs worlds. And an interesting bug with components appearing down here I have to solve at some point. We've got the specs world that is this ship. We've got the specs world that is that ship. And we've got the specs world that is everything, the universe itself. Right? Now the universe itself one is the one that manages the physics side of things. We haven't enabled the collider we just were playing with earlier yet. That's why these ships are still doing what they're doing. I need to be able to get from inside this world where we know the floor and we know its shape. We need to copy the floor from in here back out to the star world where we're going to put it in the physics objects. Yeah, makes sense. Yeah, and part of what's melting my brain is figuring out when to do that synchronization. So when we're looking at an action, so for instance, adjust floor, the world that's being passed in here is the one that is the ship itself. Why do I need the floor in the outer world? I need the collision. I need the collision object. It's going to make a shape that's going to be used by the star world. And down the track we're going to need other stuff from the floor, like we're going to need to know whether the guns can fire, whether the engines are working, that sort of thing. So there's going to have to be quite a lot of communication between those. So I could synchronize it or pass the data, or I could have a synchronization routine, I have an event, I could lock the sector. I mean, the simplest thing is to actually create a queue of all the events that gets maintained by the world. But then it's just because it's inside of a lockstep kind of container. There's a whole bunch of detail about how I want the worlds to be independent, and that kind of breaks it. So how to do it. I just need the floor shape, but I need to figure out how to shoehorn it into my current design of how worlds work. So remember I showed you before that there are lock worlds. Here's a lock world, and it contains inside of it the specs world, which I call confirmed. Later on we'll have predictions and all sorts of things going on in here. And so yeah, the space world needs to get that, and it needs to apply it somehow. I can think of a really hacky way of doing it. Maybe I should just start by doing it the hacky way, and then when it becomes a problem, then I will worry about what I do next. That's a pretty straightforward way to fix these kind of problems. So the hacky way would be to have two queues. One queue contains a list of things that we're trying to send out into the sector, and another list that contains the stuff we're trying to get back in. And it's written from the event. That would be one way of doing it. I can't think of a better way to do this right now. I'm just going to hack something up and then we're going to figure it out later. Sector. So we already have a sector event queue. What did I put in there? Create world. Okay. So this happens whenever the a new world is created in the sector. Where do we actually use these? Okay, when we call get or create world. I wonder if I ever pop it off. That's in a test. So I think I create the world, but I never actually bothered to mention it to anybody, like read it out again. Interesting. So I'm going to add another sector event, which is floor changed, and it specifies which world had its floor changed, right? And if you see a floor changed event inside sector, then you need to process that. So in sector, on perform tick, this happens every tick. After this we need to go through the events and clear the sector events. So pub function handle events, and in this we're going to pop all the events off the list and manage them all. So the events are inside this, so we say while event for event in self dot is it just called events? Yes. Why would it be an option? It's probably one of those things where I thought that I'd want to watch it from inside of. Oh, we do actually use it. Well, it's currently being used inside of the Star World link to create the ships. So that's the wrong one to use. So we'll use another one that's internal. World. It really is a world sync thing, but the word sync is being used right now for the idea of lockstep. I want basically a queue that's going to connect the different worlds that I mentioned before together. World union, worlds unite, merge worlds, ship to space. Call it ship to space because it's what it is. It's from the ships to the space. Ship to space. It's not an option, and it's not a sector event queue. It's something else. Maybe it still is a sector event queue. We'll just use the same data structure, and then down here we specify it. This one is for events from ships to the space world. In fact, we could just process it in the space world. It's probably cleaner to do it that way anyway. We wouldn't. There's all sorts of little details here about synchronization. I wouldn't really want to send events back into the lockstep worlds this way, because it would put them out of step, and all the different clients and server would be disagreeing on what they're doing. So we literally cannot do that. We can only go from into this space world, which is the one where I don't care so much about perfect synchronization, and the server's going to be more declarative about it. It hurts my brain. Okay, ship to space. New. They're creating this new event, new queue. I think we have to specify. We can have a look at this other one where we create it. So, set up events creates one. Oh, I see. It's because it gets passed in by the yeah, here's how we create a new event queue. So this is the class that's going to pass a little notification back saying you've got a particular ship has changed its floor. You need to process this now. So I was going to import all these things, and this number here specifies how many of them we can queue up. We don't really need to queue up very many. We'll just say 32. We can handle 32 events. It seems like a really small number. Let's make it really big again. So ship to space is quite a big number of events for us to process, and then in perform tick we call self.handle events. And in handle events, we're going to go through this queue, ship to space. So first we need to get our space world, let mute space. We don't even need to get it because it's really, oh yeah, equals get self dot. Oh, yeah, we do need to get it. Get world. We want the space world star. Was it space world ID? That's the one that contains all the ships in it. And then for each event, we need to match that event. We're going to have a look for the event that says the floor has changed. I think we can drain it like this. Pretty sure that we can drain an array like that. So I want that list of all possible events, which is in the sector event queue definition. It's this floor change one that I really care about. I'll just put this over here so I can see it again, because I keep forgetting what I've got to worry about. So down here in match, I want a sector event. I want create world. I don't really care about the create world event, so that does nothing. Why is it unhappy with me? Was it happy with that? No. Also, we don't care. We don't care what the variables are, and we don't want to do anything with create world here. So sector event floor changed, and what we're going to do with this is we're going to actually go and tell the sector that a floor has changed its shape. So first we need to get the world, get that world that has changed. I can guarantee that it doesn't need creating, but I could use unwrap, but I'd prefer to do it this way. And then world, so that gives you a word sync, but I actually want the lock world inside of it. Which I can get by using get lock world. I'm breaking down some of these barriers more and more. I would like it to be like nice and encapsulated, but the world is a bit messy, unfortunately. Anyway, so once we got the lock world, we want to use that fetch command again, the one that got the floor and allowed us to. We want to specify that we want a floor, and then with the floor we can now get that collider that we're interested in, because we're going to go and push it into the ship world. Well, I always actually want to get the entire floor and put it across. So let's just clone the floor, which makes you think we should go into floor and say that not only is it a world, get world, fetch the floor and clone it. Why is that unhappy? It's complaining that I haven't got two colons there like this. And I don't need these brackets here, I need to put them over here. Okay. So now we've got a ship world cloned. We're going to get the space world. We're going to put the ship world there. But I want to go to floor and make it so that it's allowed to be. Right now floor is just quite a big thing. Has a ship box and an array 2 right there, but an array 2 is like a vector, it doesn't have any data in it, it just points to data, so it's not that big. So that's good. For floor. So remember how we implemented other components in the past? So I'm making it so I can have multiple things that have floors. Rather than having one floor, which is what a resource does, we're going to have multiple things that have floors. Those things are spaceships. So we need to declare a storage. Now, this class is actually really small for the number of spaceships we have. I don't think I want vect storage. I think I want an indirect. There's like an indirect version of vect storage. And in here, I'll have a look at the different kinds of storage you can get. It's inside structs, and it's a different kind. It's called dense vect storage, and dense vect storage contains two vectors that allow the one which contains the actual data to be packed smaller. It's like a level of indirection. If you're interested in how that works, you can read up on it. But you sacrifice a small amount extra data per entity, but you save some memory when components aren't used for every entity. At the moment, vect storage would be the better choice, but down the track we might have a lot of stuff in space other than the ships. That's my current theory. Whatever, I'm going to get too worried about this. So now we can put floor inside a spaceship. Since we can put floor inside a spaceship, we can now copy it across inside the sector and place it into the ship world whenever it changes in the ship. We haven't yet sent this event to the sector. I'll have to do that soon. So now we've got the space world. We want to do something similar. Space, get lock world mute. We need to change this world, which is kind of unfortunate. We want to change it for a particular ship. The ship matches this world ID. So I need to find the ship inside of this space that has that particular world ID. I think the best way to do that at the moment is to enumerate them one at a time. There's probably some smart trick, but we'll do that. We'll enumerate them one at a time. I would rather do this inside the class called space. So this space understands how to change worlds, and it has implementation here of like handy dandy useful functions. And so the function I'm going to add here is pump function update floor. And so to update a floor, we need a floor, which is a floor, and we also need a ship world ID, which is a world ID. And with this we can now go through, and we need a copy of immutable world that we're going to change. And then we need to go through all the from the world. We're going to need to have entities, I think, probably. We need to have entities. We need to have which is yeah. Those are like trackers of what things are which. It's hard to explain. Ship, and it's like an ID number that specifies which of the entities we have, and then with the entities we can find the components. So in this case we're going to use entities to find the floor. So we want entities, ships and floors. Floors we want to be able to modify. And we're going to use world dot system data. So I'm still in the process at the moment of copying the floor definition from inside of a particular world and back into the space world. And this happens the same kind of straight after the tick that modifies the floor. It's a bit of a hacky approach, but I think it'll be okay. Yeah. So, what system data do we want? Well, we want a tuple. The tuple needs to contain needs to contain entities, res. That's what entities are. It needs to contain read access to spaceships, and write access to floor. And one thing we're going to have to do sooner or later is modify our definition of how we make a star world so that we're allowed to have floor components. So we add it to the list here. So now I can register a floor component inside space. Otherwise that line would blow up in our face. Now what we're going to do is we're going to go for every entity, ship, floor. I don't actually want to iterate over floors here. For every entity and ship and entities, ships, we want to see if this is what we're actually looking for, is to see if the ship has a world ID in it. So if I look and see what spaceship is, we'll see it has this thing called child world. Once we match child world, we've found the one we want to change the floor of. So it's a nice linear scan. Always the highest performance option to try reading every single possible value you've got. But if you actually have a look at how component systems work, the data that contains this is packed together quite closely, and so a linear scan won't take very long until we have like a lot of ships. So that's not too bad. So if the world does not match, we're going to skip it. Ship world ID. If they're not matchy, we will continue, which means drop out of the loop and try again with the next ship. So down here only occurs when they do match, and when that's done we'll break. Maybe it'll be clearer if I just say if we're looking for one where it equals. So if it equals, I'm going to put some logic in here that copies the ship across. So we use the floors, and there's a routine here that we can use. I think it's called insert. I'm going to have a look at the write storage of specs, which will tell me how to write to something. Has lots of so it's just a storage. So if I look at storage, I'm looking at something like insert or something similar. I want something I can use to overwrite. Yeah, it is insert. An insert result will return the old floor that it used to have, but I don't really care about that. So we want the insert routine takes the entity that we have, and it adds the floor for that entity. So see, here we are. So by using the entity and the floor we're trying to write, which is in a variable called floor here, on the outside here, we've just written that floor into the relevant ship. So as soon as we've done that, we're thinking to ourselves, now we need to update the colliders. So we might as well update the colliders right here. So in order to update the collider, we'll want to put I'm happy to make this routine more complicated for now by putting a collider directly inside this routine. Let's do that. Get a comma. And then here I need to be able to write to the collider, so I put write collider. I think it's called physics collider. PHYSICS physics collider. Import. And when we can write to the physics collider, so down here we want to iterate over entity ship and physics collider. So one thing that's notable about this is that we might just put make this an option. Entity ships. There was a way to make these optional. I think it was a question mark. I need to pass a reference to it here, and the reference to this. I just need to quickly look at the join documentation to remind myself how to. If there's no collider, I don't want to not set the floor. There's something in here that showed how to do an option. Where is it? I don't remember how to do this. I thought it was like the variable name and then a question mark or something similar. Oh well, we'll assume that's the magic and we'll see if that turns out to work. So I don't think that's going to work. I'm worried about it now. Oh, maybe. That's right. Yeah, we just put a dot maybe at the end, like this. I'm starting to wonder if maybe I'm making things complicated. I don't want to put this in the join. I'd rather do it outside. So say that works. We've got the floor. Now we're going to see if we can get a collider. If some collider equals colliders.get, and we specify the entity, then we're going to update the collider shape. I think it's get mute I need here. Get mute. And I need to say this is mute. I can say collider.shape equals floor dot build collider, like that. I wonder if this insert has taken it by reference and or if it's moved the floor. I'm not sure. And I just say let here for this to work. And then that should, as far as I understand, that should actually change the ship. Now the one thing we've missed is actually sending the events in the first place. So I need to invoke this. So we need to say space, which is like a class that contains useful functions to do with space. Update floor. We pass in the floor we want to update, which is this one. We pass in the new floor we're setting. We pass in the world we want to update, and we pass in the floor for it. And then we pass in the world ID. And this, lock world, I have to, I've got the same problem here, I have the same problem here, but lock world isn't the actual world I want. I need to get from the lock world the confirmed world. So up here I need to get my confirmed mute, and down here I need to get, so it doesn't need to be mute, it just needs to be confirmed. I'm not changing that one. This is a bit of a rabbit hole, sorry about that guys. I thought it would be simpler than this, but I guess we had to figure this out at some point or another. So that returns a fetch floor rather than a floor. So here, probably should return a reference to it, and then here I can say it's got a reference, and then that shape floor.clone insert. Insert probably copies it too. I'm not sure what it does. Okay, and then physics collider. Is that the name of the class that's doing the collision? It is. Okay, so why is... I haven't specified that we're talking about an F32 one. Okay. That's that done, I think. It won't compile yet, I'm pretty much certain of that. When we create a new world, we need to kind of shove the this event queue into it so that we can access it from inside the world. So get or create world, does that call add world? It calls or insert with. How do we go about getting this event queue into the world? I wonder if add world's ever actually called by anybody. So it's just called in the test. So I don't have to be too worried about that one working. I'm just going to worry about this get or create world working. So in the case of get or create world, we create a new world, which is a mute world sync. Yeah. So we're going to add a world, and we're going to add a new routine to that, which can push it in for, well, we'll do the same trick. Get lock world mute dot get dot lock dot current get the confirmed world, and we're not using fetch now, we're using insert to put a resource in. The resource we're trying to put in is going to be our array queue. So we might create a component, something like sector details or something similar. Let's do that. We don't need to do anything special for that. We just need to create a resource for this. So we'll just put the sector event queue directly in. I can't remember if we have to register a resource as being something you can put in or not. I don't think we do. So resources are like data and specs. You just can shove them in space. You just insert them. Off we go. With the default value. So here we're just going to insert our self dot events dot ship to space events. Later on we might want to make a class here that manages that. So we want to clone this. So the nice thing about these events is that you can this data structure is a multi-threaded event queue. You can clone it, and all the events that you push into one come out of all of them. But whoever takes it, takes it. So if I take one, then no one else will have to take it later. Read about it in Crossbeam. That's pretty cool. It's kind of like thinking about it like a magic pointer to a list of things, events you're sending. Okay, so we've just shoved into this world the ability to send events. We've called it ship to space. I can imagine wanting to put other data in there later. I kind of want to create a data structure for this because it might be easier to understand. So we'll create a structure for this. And we'll call it, I don't know, sector comms. And in the sector comms, we will add a public ship to space event queue here. Because that's a very lazy way of doing this. And then we will ship to space, create the structure around this event queue we're pushing into specs now. Great. So whenever we create a new world, we should be shoving this sector comms resource in, and inside the resource we should be able to find a ship to space event. So now that we can find it, we can go into adjust floor. We just adjusted the floor. We don't need to build the collider because that's irrelevant now. I don't care about that. But what we do need to do is send an event. So we need to use world dot fetch, which is how you get resources. We want to get a sector comms. We want to use this variable called ship to space inside of it. Import. We want to push a new event, which is a floor changed. I wonder if we even know what our own world ID is. So there's a good reason. There's another good thing to put in here. So pub world ID. So that a world knows its own world ID. Okay, so we need to, using ship to comms, so we'll put in a variable, let comms equal sector comms dot ship to space push floor changed, where the world ID is comms dot world ID. So the sector is going to create the structure, and it's going to populate the structure with the world ID of the ship, because the ship inside the ship doesn't know its own ID, but with comms it does. I don't know why this is complaining. That world ID, it's because here I see global world ID. Oh well, cool, okay. So this is everything we need to push this. We just need to make sure we create sector comms correctly. So we go back to sector, it'll complain that it didn't create properly because it didn't have all the fields in its data structure. So we've just added one called world ID. And the world ID field comes from, well, it's actually been passed into the function. You can see it's written up here. So that is all the things we need in sector comms. We should see in the event. That event should trigger, when the event comes through, it should go to ship to space. Ship to space should be, we should realize that floor change was called. We should then get the relevant ship, pull out the floor, turn around, get the space world, and shove the floor back into that one by calling update floor and passing the new floor in. And inside here we will find the relevant ship that matches, and then we will shove the floor into the relevant ship, and then we'll trigger a collider update. It should be very interesting to see if this works. Run. Okay, so we've got one page worth of compile issues to just rattle through. Just trying to bring this down to a size where it doesn't cover the chat window. Yep. That doesn't cover the chat window. Okay. Sector. Ship to space. It's not an iterator. And I was kind of worried that that might happen. So we'll just do it the other way. So well, ship, well, let some event in self.ship to space dot pop. Well, it's not some, but it's okay event equals ship to space pop. And you'll this. So while popping gives us an event, we keep processing. What's the next one down? Here, the world ID. This other function was expecting what's called a local world ID. So one thing I'm thinking of doing is, yeah, I've got some ideas about changing. The server and the client might have different IDs in them. Update floor. It's not implemented for entities res. Do I just call it entities? I can't remember. I think so, because that bug went away. It's not implemented for physics collider. Yeah. How can you get around this problem? Why does it even need? So if we can't get it through system data, then getting the collider is going to be very painful. Wonder why physics collider doesn't implement default. I mean, all these different things. I think there was some workaround for this problem, but I can't recall what it was. Yeah, I'm not sure how to... We could always try and get it without using it as system data, because that's... Well, if we're using write to floor, we can't... We don't need to write to the floor at this point. I'm pretty sure that system data is not using a mutable self. No, it's using it's like unboxing, so it doesn't matter if we get these later. So I can always take this one out, but I'm not sure if I can even... How do I even get that? Like, how useful is something as a component if you can't put it in a system? Or read and write to its storage? Oh, I know what's wrong. I'm using the word read when I should be using read storage. That's what's wrong. Read storage. Write storage. Write storage. So, write and read are used for resources. Storage is used for components. There we are. So the number of bugs has come right down now. Okay, so floors insert floor, and it wanted to get that value, that by value it doesn't expect a reference, so it's going to move it, so we need to put a clone in here. So at least we've only cloned it once. Cloning once is fine, I don't mind that. Cannot borrow data in a regular reference as mutable. So it's complaining because up here we got a immutable world. So we need to say that the world is still mutable here if we want to change it down below. Cannot borrow data. This dialogue has gone and put itself in a funny place. It really wants to go to the top of the screen. It's quite annoying. Okay. Still doesn't want to borrow it as mutable. Oh, I see. So this or insert with. So, okay. That makes sense. Let new world equal this. So we're making a mutable new world. We're going to do the calculation in here with the new world, like so. And then we're going to return the new world. So this inner function is called whenever we create the world, but most of the time we don't create the world, it already exists, so it doesn't call that function. So the logic to add the events to it shouldn't have been there anyway. Cannot borrow data. I need to also say confirmed mute here. Get or create world. Cannot borrow self as immutable because it's also borrowed as mutable. (172) mutable. So when we say self world's entry ID, we are grabbing a copy of ourselves, and then down here, somewhere in here, we're copying, we're accessing, because this is modifying ourself here. We can't access ourself here. So one way around this problem is to actually unpack ourselves like this. So we can say let worlds and ship to space equal, and a reference to ourselves, self, let what is self, and then these are the two variables we want, equal self, like this. So we grab those two references out, and then we just specify we don't need any other fields like this. And then here we don't need to say self.worlds, we can just say worlds. And down here we don't need to say self.ship to space, we can just say space. And then that should fix the ownership problem. Okay, so cannot borrow self is mutable more than once at a time. So 3, 2, 1, it'll create world. So in this problem is that the scope of this line is extending down too far. And part of the reason why is because we still have the ship floor here. Until we do something with this floor, we can't pass it. So we might change update floor so it does take the floor by, it does move the floor. So let's do that. So update floor doesn't take a reference to a floor, it takes an actual floor. Ship floor, it creates a clone. So we want to say, how do we dereference it and create a clone, I wonder? That's probably something simple like deref clone. Like this. And so that's an actual ship floor now. So we don't need to pass a pointer to it here. And then that should fix the ownership problem because we're no longer accessing the world below. Yeah, I'm seeing a lot of yellow over here. Okay, so it failed because I think the game or the server is still running. So I'm going to just track that down. Yeah, there's still a game running here. That's the server compiling. And there should also be a game. Yeah. So it'll be interesting to see if the collider changes when I change the floor. So for a start, I don't think this is going to be smart enough. Oh, it might be smart enough to have changed the collider right at the start. Let's see how that goes. No, it hasn't. Oh, it has. Those colliders were correct. It's just the walls overlap. So, did you see how the two ships, when they collided, they only overlap a little bit now? Oh, they're tilting. Wow, look at that one closest to us is tilting upwards. You see how it's moving away. This is the problem with 3D physics now. They're doing all sorts of funky and exciting things. I'm enjoying watching these. It's quite fascinating. I mean, it's irredeemable now. I don't really want them to rotate like that. I want them to stay somewhat flat. So I'm going to have to add some logic later that stops them from rotating too much. Just enough rotation to make it fun. Okay, so that was a nice side effect of the fact that the ships are built by adding their floors. So as we built the floors, when the game was initialized, as we did that initial building, we created the collider at that moment in time. That was pretty exciting to see going. Be interesting to see how hard it is to get it to sync, or what sort of interesting problems we get because of that hacky way of sending the events through. So I'm just curious to see how much these diverge. So let's just add a bit more floor to these two. Okay. So I'm just rotating this and bringing it down a bit. Okay, so that new area I created didn't actually trigger a floor building of any kind for either ship. They stay pretty well in sync actually, don't they? Look at them go. I would say that those are pretty much 100% in sync, which is, you'd expect them to be like, it sounds a bit silly, but I would be surprised if they weren't in sync. I think everything's going to go wrong all the time. So when things work, I'm always like, oh, it did work. But in theory, they should have been in sync, so that makes sense. I don't know why they collide. So what I'm commenting on is the two games showed the ships in the same place, as I'd expect. But what I don't understand is why the colliders didn't change when I built the ships later. So, yeah, that's interesting. This has comments whenever the colliders change. There's a lot of action submits as well. I might just find where it says action submit. Oh. I need to remove match case. I need to figure out where it's printed out. Because somewhere I've got a debug message that's printing the action constantly. I'm just going to jump into this file and see if I can track down where submit action goes. Confirm action. Yeah, I'm not sure why the server is writing that out in the first place, which is a little bit annoying since it's spamming. It'll be somewhere in the networking. I'm just going to have another look and see if I can spot. I could of course put it in the debugger and then put a breakpoint in that, but it just seemed like a pain in the butt. I'm just going to take a couple of minute break. Let me just pilot an erratic course and leave you to watch that. I'll be back in 2 if anyone asks you in the chat. Hold on. Oh, it's interesting. Nothing. That everything's still on the screen. I was kind of expecting that it would have drifted off by now. Just slowly drifting around there. Cool. Let's quit out of that. So one of my problems is that the action submit that's being sent by the server, that's being sent by the client, is so verbose that it's drowning out all the other console output on the on the server. So I just want to quickly find this and tone it down a bit. Thanks, I appreciate that. It is looking pretty awesome. There's so much stuff. It's going to be so exciting. I'm really looking forward to docking my first ship. Okay. Thanks for sticking with me through this journey. Now, floor tiling. What world? Where was I? Okay, so I expect the problem is going to be in SGNet, because that's where the client and connection are, and I expect probably in server. I'm going to process an incoming message, handle messages. Yeah, that's probably it there. You're printing out every message we receive. So if we run the server again, the disadvantage is how chatty it was before was kind of useful. I might want to limit it to everything apart from the player input message or something, because it's nice to be able to see placing modules and stuff. So you see how it says updated collider and world with values? So I'm wondering if I need to do something to make sure that it notices I changed the collider. It might be something as simple as, even if you change the shape, it doesn't notice. So when I run the game again, it's not spamming anymore, so that problem was solved. So if I add a floor, yeah, it says updated collider and world. It's really weird that that doesn't apply the way you'd expect. It's quite hard to pilot at the moment, because this extra region I just added has not had its not been added as part of the floor. Let's just restart this whole thing. So there's the server again. So, I mean, you know, there are ways I could write a unit test to confirm why this isn't working, but it just seems more fun to try and do it by hand. So updated the collider in the world with values. So if the collider has some collision object, by the way, selecting some text is like pausing this text, has a collision object handle offset from parent, isometry, quaternion, translation. I wonder if there's some rationale why an old version of the floor is what's being used somehow. Can I think of any reason? Like if it chose the wrong world to notify, but that doesn't explain why the two different worlds. Floor build. Oh, the server's paused. The client's having a spaz, which isn't very surprising. It was a bit drastic. The client essentially has to pause now for a while the server catches up, which is like a really weird situation, and the client's just not designed for that. Because I paused the server. That's a funny thing about programming, is that unless you write some code to handle a situation, your code just won't handle it. It simply won't. Interesting how the modules ended up looking like that. Oh, that's another point, is that having restarted, I imagine now... Okay. So we haven't got the new colliders even though we restarted. Which also makes sense. It's basically the same as building them anyway. Just trying to figure out if this tells us anything interesting. It's fun watching that cursor jump around. The reason why it's jumping around is a bit hard to explain, but it's cool to see it. Okay, so what I could do is I could create this entire situation as one giant unit test, where I create a sector and I have a floor, and I create an action that modifies the floor, and I check to make sure that the collider is changed in the other floor, and then we step through and debug it all, and it just sounds like a giant pain in the ass. We could just step through in a debugger and sanity check that this is working without making a unit test. That saying that out loud sets off alarm bells in my head, but I'm going to do it anyway. Maybe because I'm on stream, I'm just always rushing in a way that I wouldn't normally do, or wouldn't be as tempted to do if I wasn't on stream. Handle events. If the floor changes. So what we're going to do is we'll run the server as a debugger. So we'll go run debug and choose that we want the server to be debugged. And it complained it couldn't start up because the server's already running. So I mustn't have realized that there's a server there. So we'll try that again. Okay, so the server's now running in the debugger. So we'll start the game, and we'll exercise the bug on the server. So to exercise the bug, what we'll do is put a breakpoint here. So I was aware that this might be triggered while we were initializing, so I don't want to do it earlier. If we go in here and we say floor build and we draw a box, hits the breakpoint, which, exactly what I wanted to happen. So I'm just removing this console window but making it still visible. It's a bit fiddly on the other screen. Okay, so I need a debug window. There must be one around here somewhere. Why can't I see a window for debugging? This seems to be the debug window, the console window, but it's a bit weird. It hasn't got all the nice doodads you'd expect a debug window to have. I don't know why it's. I was expecting to see having multiple DPI monitors messes some of the stuff up in a way that's really annoying. Normally we'd have all the variables and stuff visible here. Now it's getting a bit peeved. Oh, I just realized that the console and the debug view are separated. So there's the one I was looking for, which is a list of all the variables that are nearby. So you can see a call trace of which functions are called which. Here we can see the variable world ID, which has currently got the value 1. We get the first thing we do is get the ship floor. And so the extents seem fairly large. And then we get the space world, and we step into, so let's get in the world. think we just stepped out and missed our chance. Okay, so I'm going to quit the client and run the game client again, because I'm expecting the other one won't be able to sync up. And we're going to build some more floor. Here we go. And again, I hit the breakpoint. So I want to go inside of update floor, which is this function here. So put a breakpoint here and run some more. Okay, so it did actually make it in here. So the first ship we're looking at is the correct one, so it has the right ID. So we want to add a clone of the floor here, and then after cloning the floor we want to build a collider of it. We don't even need to clone the floor actually, because we're passing it in by value, so we can actually do a move here that just saves another copy. So we'll do that, put that down there. That way we're not doing the floor twice. So I've been very wise here and changed the code halfway through. I think it's very likely that the problem here is what if I have to call to change the shape? It's very likely that the problem here is something to do with the specs physics as opposed to me specifically. Let's see if the specs physics are like, you know, changing an existing physics collider probably needs me to do something special. I wonder how it decides whether it needs to modify the other collider or not. I wonder if I need to do something to update the physics body to use this new shape. And it could be that that's the problem. I need to change the body so that the new shape is used. What does the InPhysics collider have to say for itself? I actually find the InPhysics documentation to be annoying. I'd rather have the standard stuff. So I'm going to go to docs.rs and look for InPhysics instead. So the wrapper we have is a wrapper around this one. Okay, so it doesn't even have it doesn't show any documentation at all. Probably because InPhysics is like it's like physics 2D, physics 3D. This is InPhysics 3D is the one we want. Now let's have a look and see how colliders work. Object collider. Yeah, user data, removal data. With the collider shape and a shape handle. And how do the physics bodies work? So when we created the physics body earlier, we probably put some sort of a handle in. So I'm just going to kill the debugger and disconnect the game, quit the game out. So that's all stopped now. So in space, we had a physics bodybuilder and we had a collider, physics collider builder. I'm just wondering if the physics collider builder does something smart with how it connects to the other one. mean, do I need to delete the old physics collider builder and insert a new one? I mean, it's still interesting that it worked at one time. That we could change it once, but we couldn't change it multiple times. Yeah, I think we're going to use Physics Collider Builder to create another collider every time the floor changes. Let's just try that. So rather than take the existing collider and modify its dot shape, we're going to nuke the existing collider and create a completely new one. And in the same way that we nuked the floor and created a completely new one. So we say colliders insert entity. This, I just pasted that there, and it's from here, and for from we use collider shape. I'll just use a variable that I've just made up called collider shape, and then you call build on the builder and immediately pass it into insert. So that's how we're going to update the collider. And then I'm just going to grab this line in the middle here, floor.build collider, and put a let statement around this. So let collider shape equal floor build collider. So what I'm doing is, instead of trying to modify the shape and expect the specs physics to synchronize that, I'm just completely nuking the collider and building it again, and expecting the physics engine to notice and to rebuild that. So hopefully that will fix this problem. Just starting the game up. Okay, build some floor. Oh wow, it panicked. So we tried to call unwrap on a none value. It said, when I dragged it across to show you, this window just jumped in size. This is like a bug in C-line. So inside of, I wonder who called unwrap on a none value. And then the client died because it's panicking because there's a mutex between Godot and Rust, and after the Rust simulation panicked, it damaged the mutex and put it into a poisoned state. And so every frame now, it's trying to interact with that singleton and can't lock the mutex so it's still poisoned. Strictly speaking, the client should detect that and delete the data and reconnect to the server, rebuild the data and reconnect to the server, or something similar, something else drastic, or just generally just say, you know, desync error. I wonder who called this unwrap. Yeah. I'm not sure what's going on there. If it was inside the debugger, I wonder if that would catch the exception. So I'm just going to restart in the debugger. So I've just pushed the debugger start button, and we'll run the client again, and we'll try and extend the floor again, and we'll see if it blows up and catches it in the debugger, but it might just have the same error and not catch it. Okay, floor build did nothing. It's not able to connect to the server. Oh, it's setting the breakpoints that I placed in here earlier. Let's continue through without the breakpoints. And it immediately had the same problem as it had last time. I wonder if I need to turn on exception handling somehow. Because I've got no stack trace, I'm kind of stuck. So often when you have a panic like this, you end up with a nice stack trace. But I think we can probably safely assume that recreating the physics collider is not happy. I bet that the physics synchronization system does not expect the physics collider to vanish and reappear. There was a synchronization system in space. That's the space module. In here, we were, well no, that's right, in the frame by frame thing, update, here we are, we call space state, and then from there we say run now, and we sync colliders, and in sync colliders we do this, sync colliders to physics system. It has a positions reader ID and a physics colliders reader ID. These are both options. And then we collect all components, collect all component events, iterate over the colliders, and position components with an ID index that exists in either of the collected handle inserted events, handle modified events, handle remove events. And so we should have this update collider here is the one that didn't seem to actually make the changes we expected. Modified collider with ID blah, collider handle, collider world. So add collider has got a lot of stuff, body handles, rigid body, map, ground, some entity, rigid body map, all. I was going to move this debug window because I can't see the chat. Okay. I'm just trying to figure out why when I change the floor of a spaceship in here, it doesn't affect the collision area as seen by physics. So that's just a reminder of what our current goal is if you weren't following. And so I'm kind of looking through the specs physics library to try and see if I can read in their code what could possibly be wrong. Map or body part handle ultimate default. Create the actual collider in the in-physics world and fetch its handle. Let handle equal the collider new. It has a position, density, material, margin, collision graphs, linear sensor, build with parent. So, at what point do we get the shape? Okay, so we start with a collider handle from the shape handle. Okay. So we have a physics collider. Add collider. So yeah, I'm getting the feeling that update collider does not do everything. It doesn't do the part where it actually modifies the shape handle It's not. It's like for changing densities or something minor like this. It's not designed for changing everything about the collider, which is rather annoying because we're trying to change. We're trying to change the collider's actual shape here. So it's changing something called collision groups. So they're obviously expecting quite a small number of things to change. Collider world. Okay. So set collision groups. Okay, so it doesn't have set shape. So there's an add which takes a shape. So we really do have to remove and re-add the shape. But removing the shape seems to blow up in our face. But it's interesting that changing the shape from this single cuboid to my compound one is noticed, but this other one is not. This other option is not noticed. Okay, so we can't use this approach. So we need to use the older approach, which was to modify it in place. That's what it looked like. Something like this. And then we had, this is the new approach now at the top. If it doesn't work, causes a crash. Yeah. I think we're getting close to our scheduled transmission. I'm starting to get quite tired, and this particular problem is a little bit too much for me to handle at the moment. I think we've done some pretty good work tonight. We managed to make the ships rotate in space and crash in really interesting ways. We managed to make the colliders initialize, at least to start off with, from the floors. I got some synchronization from the space world so that I can get the floor out when the space world's floor changes and put it in the sector, even though it's not applying properly to the collider. I think it's a specs physics synchronization problem that I need to track down and put in as a pull request or something for the specs physics team. There's a lot of other stuff I want to cover, like moving your player within the ships and rotating the camera. Rotating the camera will be a big one. Going in and out of the console, those sort of things will be fun stuff to do next. So that'll be the next thing to focus on, I think. But first I need to fix this particular problem where if you need to be able to extend your ship. How much do I care about extending your ship at this point in the game design? There's a good chance I'm going to actually just put this collider problem to bed for now and just ignore the fact that the colliders don't update and that the colliders don't work properly. I'll need it later, but right now it's actually not that important, really. So I really appreciate you joining me. This is the Recall Singularity, a factory space game in development by just me. Join me on Twitter. The link, it's pretty obvious. Just Google Recall Singularity, read some blog articles, join us on Discord. Thanks for watching, and I hope to catch you again really soon. And with that really slick sign off, I will now try and find the button to end the stream before I forget. And now that I look, I realize I never actually started recording this one, so it's going to be on Twitch only. I'm sorry if you just watched on Twitch because it wasn't on YouTube. Good night, everybody. See you later.